Hey, hello, Earth Science class. Good to be here. Hey, this is lesson number 4, and you're going to get 2 for the price of 1, so to speak, because we're going to do 2 experiments, and uh, it's going to explain why global warming won't cause the um, ice caps melting to raise the level of the water. You may say, well, that's what they say. If it gets too hot, it's going to melt the ice caps and the water's going to rise and we're all going to be underwater. Well, it's not true. In fact, it's kind of just the opposite. And I'm gonna prove it to you. Now, the thing is about global warming, if that were to melt all the snow on the mountains, that snow would turn into water, would run down in rivers and fill up and end up in the ocean and fill up the ocean and make the ocean level rise. That is true, and that is happening, sadly enough to say. But the fact that some people believe that the polar ice caps melting, like Antarctica and the North Pole melting, would raise the water is not true. And here's how I'm going to prove it to you real quick, like, well, not super quick, like, but with a little help of a time lapse. I'll show you. So what I'm going to do is I'm going to take a glass of water, and I've got ice in it. Think of that as an ice cap, okay? And there's the ice cap, and I've got a blue mark. Hopefully you can see that blue mark right there. That's at the level of the water and the ice, okay? Now, so what I'm going to be doing is letting that ice melt, and we're going to see what happens. Now, just to give you a little bit of a clue, what happens when water freezes? When you put a ice cube tray filled with water in the freezer, what happens? Well, the ice freezes, right? You have ice cubes, right? Are those ice cubes bigger or smaller than when you put them in when they were water? Well, here's what happens. Ice is one of the few things that when it forms, it actually expands and is actually bigger than it was because the crystals form an octagon formation and actually separate the molecules. They're actually farther away than they were when they were liquid, which is really one of the main differences about water versus other substances. Okay, so what's going to happen now is the ice cubes are going to melt, and I'm going to show you with time lapse. And here we go. Hi, I'm back, and we're going to show you what happened to the ice when it melted. So I've got my glass here with the blue mark on it, and I'm going to try to show you again. Can you see that? And you guys can try this at home. If you take a look at that, where the blue mark is and where the water is actually lower. It didn't rise up and engulf the land. The ocean did not get bigger. It actually shrank a little bit. Now, why is that? Well, because the ice cubes were taking up more volume when they were ice. When they melted, they got down to their smaller size, which took up less volume in the water, so the water actually went down. So we're not talking about polar ice caps and Antarctica melting and raising the sea level. It actually would lower it a little bit. Now, the thing is, if there were that much heat to melt the ice caps, then we'd have a big problem in the other parts of the world where the mountains had snow on them. Those would be melting and those would be running down into the ocean and raising that level. Okay, but if we just are strictly talking about the ice at the ice caps, the polar caps melting and raising the level of the water, that wouldn't happen. Okay. The second thing I'm going to do is I'm going to see how long does it take water to freeze. That's kind of a complicated question because it depends on how cold the water is when it starts. Is it pure water? What's the temperature of your freezer? Is it at minus 32 degrees, positive 32 degrees, 0 degrees? Is it a sub-zero freezer? Those all things, can change how fast something is going to freeze. What I'm going to do is I'm going to take a glass of water, and I'm going to put your typical Carnotaurus that your grandkid might have hanging around, which he does. I'm going to put it in the water, okay, and then I'm going to take this to the freezer, and I'm going to freeze it, and I'll let you guys know in my next video how long that took to freeze the Carnotaurus in the glass of water, okay? We would predict, normally just from having done experiments before and having other scientists do experiments, you take about 3 or 4 hours probably to freeze water at your average freezer in your average house, okay? But you guys are welcome to try that at home and see how long it takes your glass of water to freeze. Okay, well, this is Doc out, and I'll see you on my next video for Earth Science, and we'll talk about how long it took to froze. It'll just be a really quick snippet, and I'll just show you the frozen dinosaur in the water, okay? Thanks, and I'll see you in my chat rooms and in my office hours at 8 o'clock for my office hours and 11 o'clock in the chat room. Make sure you're watching these videos so that you can get in on the prize. Take care, bye.